In this tutorial, we're looking at 2023 Paper 2, Question 9, and it's mostly about area and volume. In the first part of this question, we're told that Ava is exploring different shapes of tiles. And in A part I, we're told that one of the tiles is a square shape, and that has an area of 140 centimeters squared. We're asked to work out the length of one of the sides. Well, obviously the thing we know about a square is that all the sides are the same. So what I might do is start labeling the length as x and the width as x. To get the area of a square, it's simply the length multiplied by the width. In other words, x multiplied by x. So the area of the square is x squared. And the question told me the area is in fact 140 centimeters squared. So I can say x squared is 140 centimeters squared. And if you simply get the square root of both sides, you end up working out that x is 11.8 centimeters. And that's your final answer for the first part of this question. In the second part of this question, we're told that alternatively, Ava can use a hexagonal shape for her tile. But the area of this tile will be exactly the same. It's still 140 centimeters squared. We're told that a hexagon is comprised of 6 equilateral triangles. Remember that an equilateral triangle, all the angles are 60 degrees and all the sides are the same. So rather than drawing out the whole shape here, I've just drawn out one of the equilateral triangles. If the area of one full tile is 140 centimeters squared, obviously the area of one of these triangles, you divide it by 6. 140 divided by 6, the simplest way that we're going to write that is 70 over 3. So the area of this is 70 over 3. And the question is to work out the length of the side of one of these triangles. Now, there's a couple of different formula that we have for the area of a triangle, and there's a few different ways that we could do this. But as far as I'm concerned, we should use the one that we learned in trigonometry. The easiest one to use here is the fact that the area of a triangle is a half AB sine C. Remember, where A and B refer to two sides of the triangle, and capital C, that's the angle in between those two sides. So I'm going to sub into this formula now. The area of this triangle, I know it's 70 divided by 3. And a half is obviously a constant, so I'll write it down. All the sides of this triangle are x. So my A in this case is going to be x. My B in this case is also going to be x. And sine C is going to be sine 60, because all the angles in this triangle are 60 degrees. So now let's just group our like terms. So I have 70 divided by 3, and on the right hand side, x by x is going to be x squared, and the constants that I have are a half times the sine of 60. So in order to get x squared on its own, what we would do next is we would divide both sides by a half sine 60. If you plug that into your calculator, 70 over 3 divided by a half sine 60, that works out as 53.88. And if you divide the right hand side by a half sine 60, you're just left with x squared. So now it's simple enough. Obviously, to get x on its own, we're going to get the square root of both sides, and our final answer in this case is going to work out as 7.3 centimeters. So if the area of one of these triangles is 70 over 3 and it's an equilateral triangle, each of the sides must be 7.3 centimeters. That's your final answer for part 2 here. Okay, in B, we're introduced to a more complicated potential shape for the tiles. And in this case, it's symmetrical, so we kind of just need to look at either the top half of the diagram or the bottom half of the diagram. We're told that the distance from A to D is 8, the distance from A to E is 6, and the distance from E to D is 4 centimeters. And we're asked to find the value of alpha. We're actually given the answer. We're told that alpha should be cos inverse of 7 over 8, but the way we might view this is the question is basically just find the value for alpha. So to be honest, to start this off, we should ignore everything other than the triangle AED. Because we've been given a non-right angle triangle and all 3 sides. If you know all 3 sides in a non-right angle triangle, it's relatively easy to find a value of the angle if you use the cosine rule. So you should go to your maths tables and you should take down the cosine rule. The cosine rule tells me that a squared equals b squared plus c squared minus 2bc cos a. The format that the cosine rule is written in, it's kind of tailored towards finding the length of a side. But in this case, we're trying to find the measure of an angle. So before you sub in, now you don't have to do this, but I would advise you to do it. Before you sub in, it's usually a lot easier if you isolate cos A first. So if you're rusty on this, go back over the tutorial we did on the cosine rule, and we practiced this a number of times. If I'm trying to isolate cos A, well, the first thing I'd do is I'd bring the b squared and the c squared to the other side. So just bring them across and leave the complicated term at the end on this side. Now we're just going to divide both sides by minus 2bc, and we get that cos A is equal to a squared minus b squared minus c squared over minus 2bc. Basically, you've just taken the formula in your maths tables and you've rejigged this so that now we can answer this question in just one line. We're looking for the angle alpha. So that's obviously our capital A, that's the angle in this case. And that means that what you sub in for small a has to be the side opposite alpha. So in this case, a squared will simply be 4 squared. And then our b, we're going to sub in 8, and our c, we're going to sub in 6. And then it'll just be one line, we'll plug it into our calculator and we'll get our answer. So if we sub in, instead of our angle A, we now are using angle alpha, and opposite alpha, small a we sub in 4, then b and c are 8 and 6, but it doesn't matter which one is b and which one is c. And all you should do then is just plug that entire fraction into your calculator and you get 7 over 8. Now, be careful of the format you need to leave your answer in. It's said to prove that alpha is cos inverse 7 over 8. So obviously you just bring the cos over and you get cos inverse 7 over 8. And that's your final answer for B part I. In B part 2, we're told that the angle ADC is 90 degrees. And obviously then that this angle here is also 90 degrees. And we're asked to use this information to find the area of this shape. Well, first of all, I would now just ignore the bottom of the diagram. We're trying to get the area of the whole thing, but let's just get the area of this triangle and then multiply it by 2, and that's our final answer. So the question boils down to find the area of this right angle triangle. The easiest way to get the area of a right angle triangle is to multiply the base half by the base by the perpendicular height. In other words, I know this, I can call this my perpendicular height. I just need to find this distance. If I can find the distance from D to C, then that's what I'm going to refer to as the base. And then I can get the area of the triangle by half the base by the perpendicular height. The first thing you might do is, we worked out in B part 1 that alpha is cos inverse of 7 over 8. And if you plug that into your calculator, that actually works out as 28.955 degrees. So if I know this angle, I can easily get the value of x. Remember, if we have a right angle triangle, you should be thinking about what you learned at junior cert about trigonometry. I know that the opposite side is x and the adjacent side is 8. So if I'm looking for opposite and I have the adjacent, I should be using tan. I can say that the tan of the angle alpha, which is tan 28.955, is equal to the opposite, which I'm referring to as x, over the adjacent, which in this case is 8. Now, in order to get x on its own, all we have to do is multiply both sides by 8. So x is going to work out as 8 times the tan of 28.955. And if we plug that into our calculator, it'll tell us this distance dc. So if you plug that into your calculator, x works out as 4.42626. So now I can say that the base of my triangle is 4.42626. And in order to get the area of a triangle, it's just a half by the base by the perpendicular height. So let's look at that now. If I want the area of this shape, it's going to be a half multiplied by 4.42626 multiplied by the perpendicular height, which is 8. But remember, that'll just give me the area of the top half of the diagram, but there's also a bottom half of the diagram, so we have to double that. So at the end, I'll just multiply by 2. And this will give me the area of the entire diagram. So when we plug this into our calculator, our final answer works out as 35.41 centimeters squared. And that's all you have to do for B part 2. Okay, in C part 1 of this question, we're given two different circles. We're given the unit circle, which has an equation x squared plus y squared equals 1. Obviously, the center of that circle is the point 0, 0, and the radius of that circle is a 1. And that's probably the most important thing in answering the first part of this question. And we have the circle S. Ultimately, the goal is going to be to get the equation of that circle. But for the moment, we're just trying to find the coordinates of the point Q. And we're told that the angle QOP is 45 degrees. So the first thing we might do is just draw that in. You know, draw a line from Q to O. And now we can say that this angle here is 45 degrees. Now remember that you know the radius of this circle, so you know the distance from O to Q must be 1. Now we're going to form a right angle triangle. We're going to join Q, we're going to draw basically a vertical line that joins Q to the horizontal, and we'll note that that's 90 degrees. You might also notice now that this must be an isosceles triangle. If that's 90 and this is 45, then the angle here also has to be 45. I'm not going to bother writing it in because it's going to clog up my diagram. Now, we're asked to find the coordinates of Q. In other words, I need to find the x coordinate and I need to find the y coordinate. Well, obviously the distance from O to here, if the distance from here to here was 3, then that would, that would be the coordinate -3, and that would tell me that the x value is a -3. Obviously that's not the distance, I made that up. But the point is, if I can get the distance from there to there, it's going to tell me what the x coordinate is. Again, I have a right angle triangle, so you should just be thinking about junior cert trigonometry. I know that this angle is 45 degrees, and the distance from O to here can be considered our adjacent in this case. I want to know what the adjacent is. Well, I know that the hypotenuse is a 1. If you're dealing with adjacent and hypotenuse, you should be thinking about cos. I can say that the cos of the angle, the cos of 45, is equal to the adjacent. Let's for the moment call it k. So instead I might just refer to that distance as k divided by the hypotenuse, which is 1. In order to get k on its own, I just multiply both sides by 1, so you get 1 cos 45, and if you plug that into your calculator, it works out as 1 over root 2. In other words, the distance from the origin to here is 1 over the square root of 2. Now obviously this is the negative part of the x-axis, so that doesn't mean that this coordinate is 1 over root 2, it means that this coordinate is -1 over root 2. So that's the x value. Now another thing, we could repeat that all over again, but we did mention that this is an isosceles triangle. So because it's an isosceles triangle, if this is 1 over root 2, then this, the opposite, is also 1 over root 2. So that tells me I know the distance from Q to the base is 1 over root 2. In other words, if you just think along the y-axis from 0 until you get level to Q, that distance is 1 over root 2. It obviously implies that the y coordinate here is 1 over root 2, and likewise the y coordinate over at Q is also 1 over root 2. So that tells me the coordinates of Q must be -1 over root 2, 1 over root 2. Okay, in the second part of this question, we're given 2 more pieces of information. We're told, first of all, think about a tangent that goes to the big circle that goes through P. We're told that if I draw a tangent to the big circle through P, then that tangent goes through the center of the smaller circle. We're also told that if we draw a tangent to the point Q, a tangent to the large circle, then that will also go through the center of the circle. And that's enough information now for us to find the center of the small circle and the radius of the small circle. First of all, let's start off with the point P. I know the point P is obviously on the x-axis, and I know the radius of the big circle is 1. So obviously the point P has to be the point -1, 0. And you should recognize that obviously this here is a horizontal line, and we're referring to a tangent. So let's draw a tangent to the big circle that goes through P. A tangent to the big circle that goes through P might look like that. Now my diagram might not be perfect here, but the point is, if it's a tangent that goes through P, and if this line is horizontal, then the tangent has to be vertical. In other words, the center, and I know the center of the small circle lies on this tangent, so it has to be just directly above the point P. In other words, let's refer to the center of this circle as the point W for the moment. If this is the point -1, 0, I draw a tangent, every point on this line, the x value has to be a -1. So I know for a fact that the x coordinate of the center has to be -1. That's the first piece of information dealt with. But now let's just ignore that for the moment, and let's now try and find the y coordinate of the center. The other thing I know about the center of this circle is that it goes through a tangent to the point Q. So let's draw that tangent. A tangent to the large circle that goes through Q might be around there. And I know that somewhere on that tangent is the center of the small circle. we have a load of information already. We've worked out previously that Q has coordinates -1 over root 2 and 1 over root 2. In order to find the y coordinate here, I think that there's a number of ways of doing it, but in my mind the easiest way is that we should start thinking about slopes. In the first part of the question, we were concerned with this line. So obviously the distance from the center of the circle, the line from the center of the circle to the point Q is perpendicular to the tangent. That comes from one of our theorems. So what I'm going to do here is I'm going to find the slope of the line from O to Q. And then if I know the slope of this line, the perpendicular slope is the slope of the tangent. And if we know what the slope of this tangent is, we'll be able to work out the y coordinate of the center. So first of all, remember the origin is obviously the point 0, 0. So you could use your formula here. There's a formula y2 minus y1 over x2 minus x1 to find that slope. But the easiest way to do it here in my mind is to just use the rise over the run. So let's imagine here, if I'm trying to find the slope of the line from O to Q, well in this case the rise is obviously 1 over root 2. We worked that out in C part 1. And the run is also 1 over root 2. So the point is that if I want the slope of the point from O to Q, the slope is simply the rise, which is 1 over root 2, divided by the run, which is 1 over root 2, or in other words, it's just 1. It's 1 over root 2 divided by 1 over root 2. Now, if you're following that method, if you always think of it as a rise and a run, remember, obviously, that line is decreasing. So in fact, the slope is a -1. So the slope of O from O to Q is -1. That's a useful piece of information. The slope from O to Q is -1. And if that's the case, I know that the perpendicular slope, the slope of this tangent, well, it must be 1. Because if you think about that, the product of perpendicular slopes always gives you -1. If I take this slope, which is -1, and I multiply it by this slope, which is 1, 1 by -1 gives me -1. So now I know the slope of this line, and I'm calling the center W, so the line QW is 1. Now, in order to find this coordinate, for the moment, let me call it y1. Well, an easy way to get the slope of a line is y2 minus y1 over x2 minus x1. And what I want to do now is, again, I'm ignoring that. All I'm concerned with at the moment is the distance from W to Q. Let me refer to this as x1, y1, and this as x2, y2. If I was to work out the slope of this line, it would simply be 1 over root 2 minus y1, whatever that is, divided by -1 over root 2 minus -1. All I'm doing there is subbing in y2 minus y1 over x2 minus x1. But the point is, based on what we did there with the line OQ, we've actually already worked out that the slope must be 1. So I can now say that that is simply equal to 1. Now I have one equation and one unknown, so I'll easily be able to find y1, the y coordinate of the center of the small circle. So where I left you there, we had a relatively simple equation to solve. We have 1 is equal to 1 over root 2 minus y1 over -1 over root 2 plus 1. What I decided to do on this line was multiply everything by the denominator. In other words, I'm multiplying everything by the bottom of the fraction, so that basically the left-hand side becomes -1 over root 2 plus 1 equals 1 over root 2 minus y1. And then I just brought my unknown y1 to the left and everything else to the right. And I plugged this into my calculator and I've worked out that y1 is -1 plus root 2. In other words, now I know what the center of this circle is. The x coordinate is a -1, we worked that out at the very start, and now I can say what the y coordinate is. The y coordinate of the center of my circle is -1 plus root 2. So that's your center. Now the last thing we need to do is work out what is the radius of this circle. Now there's a couple of ways of getting the radius. A long-winded way would be, we know the coordinates of Q, and we also know the coordinates of P. So we could use the distance formula. If we get the distance from P to the center, or if we get the distance from Q to the center, either of those refers to the radius, and either of those is acceptable. But you should remember the work we've done on when a circle is a tangent to the x-axis. This circle is a tangent to the x-axis. In other words, I want you to just look at the distance from P, which is at the edge of the circle, to there. That is the radius of my circle. But that is a vertical line. And obviously then we can work out what this distance is. If this is the point -1 plus root 2, then the distance from here to here is obviously this y coordinate. It's just the distance -1 plus root 2. I'm just trying to point out to you that the distance from there to there has to be -1 plus root 2. Likewise, the distance from the x-axis to the center also has to be -1 plus root 2. So remember, we've studied that if the x-axis is a tangent to the circle, then the radius will be the same as the y coordinate of the center. So the radius of this circle is 1 plus root 2. And the center of this circle is -1 minus 1 plus root 2. And that's your final answer for C part 2 here.